Math 138, Test 2, Spring 2013, Problem 5. A particle is moving on a number line. Its position s in inches at time t seconds is given by the equation s is equal to 2t cubed minus 3t squared for t greater than or equal to 0. Part A, when is the particle at rest? So the particle is at rest when its velocity is equal to 0. So you find the velocity by finding the first derivative and set it equal to 0. So the derivative of 2t cubed minus 3t squared is 6t squared minus 6 times t. You set it equal to 0. You factor out 6 times t, and you set each factor equal to 0, and you get t is equal to 0, t is equal to 1. So the particle is at rest at time equals 0 seconds and time equals 1 second. So at the beginning of the motion and then after 1 second. Part B, when is the particle moving in the negative direction to the left? So this is going to happen when the velocity is smaller than 0. So I have a little chart over here. So first the particle starts moving at 0, at time 0 of course. Then it's at rest at time equals 1 second, and then it's never at rest again. That's what we found in part A. There's only one point once it starts moving when the particle is at rest. So I just have to figure out when the velocity is smaller than 0. Is it to the left of 1 or to the right of 1? So I choose a point, let's say 1/2 between 0 and 1. I plug it into my velocity, evaluate it, and you get -3/2, which is definitely smaller than 0. So I have negative velocity for a point that was tested between 0 and 1. And then I choose 2 from the other interval. You could have chosen any other point to the right of 1. And I evaluate my velocity at this point, this chosen point. I get velocity is 12, which is greater than 0, so the particle is moving in the positive direction at any point here after 1. So I just write my answer that the particle is moving in the negative direction, so to the left, between 0 and 1, because this is where the velocity is smaller than 0. This is my answer. Part C. Find the total distance the particle has traveled during the first 3 seconds. So first I have to figure out how far it moved from this position, from the position where it was at 0, at time 0, until it rested at time equals 1, and then find out how far it went from time equals 1 to time equals 3 seconds. So from t equals 0 to t equals 1, it moved 1 inch. How do I find it? I just find the difference between the positions of the particle. So I evaluate our original function s, this one, at 1 second, evaluate it at 0, find the difference, and take only the positive difference. So that's why I have the absolute values around it. And then from time equals 1 to time equals 3, you do the same thing. So you evaluate where the particle is at 3 seconds, where the particle is at 1 second, find the difference, take the positive only, that's why the absolute value. So it moved 28 inches from the 1 second to 3 seconds, and then you just add these two distances. So 1 second, first it moved 1 inch, and then it moved 28 inches, so the total is 29 inches. Problem 6. Each side of a square is increasing at the rate of 5 centimeters per second. At what rate is the area of the square increasing when the area of the square is 64 quadratic centimeters? So here's my pretty square. Each side I labeled as x. You could choose another letter you could choose any letter you want as long as you stick to the same letter throughout the entire problem. And the problem says that each side of the square is increasing at the rate of 5 centimeters per second, which means that the derivative of x with respect to t is 5 centimeters per second. We have to find how fast, at what rate is the area of the square increasing, so what the derivative of the area with respect to time is. At the time when the area of the square is 64 quadratic centimeters. Oh, I forgot a little square here. So if if the area is 64, then the side of the square is going to be 8 at that point, right? And so I start by writing my equation relating the area and the side of the square. So I know that the area of the square is x squared. Then differentiate using implicit differentiation with respect to t. So the derivative of the area is the a dt, or a prime. And the derivative of x squared is going to be 2x, but you have to multiply it by dx dt because we're differentiating with respect to t, not with respect to x. And then we have to figure out what this derivative of area is when x equals 8 over here. Dx dt is given to us as 5. So the a dt is going to be 2 times 8 times 5. 2 times 8 times 5 is 80 quadratic centimeters per second. You write your answer here in words, and that's it for this problem. Problem 7. Two cars start moving from the same point. One travels south at 15 miles per hour and the other travels west at 20 miles per hour. At what rate is the distance between the cars increasing 2 hours later? So from the same point, one car starts moving west, the other starts moving south. So the distance between the starting point and where the car currently is, I labeled as x over here for the horizontal distance. The car moving west, and for the car moving south, the distance between where the car currently is and the starting point is y. You could have chosen other letters. As long as you use the same letters in the entire problem, it's going to be fine. And then I labeled the distance between these two cars as z, and we can see that all of these distances are increasing as the cars are moving away from the starting point. So z is also increasing. Then it says that the car traveling south is moving at 15 miles per hour, which means that the derivative of this distance y with respect to time is equal to 15 miles per hour. And the car that's moving west is moving at 20 miles per hour, which means that the derivative of this distance x with respect to time is equal to 20. Our job is to find how fast z is changing with respect to time, z, this distance. At what time? 2 hours later, so 2 hours after they start, at t equals 2 hours. And at time t equals 2 hours, x, the distance of the first car, of the west car, is 40 miles, because if this car is moving 20 miles per hour, it means that in 1 hour it's going to make 20 miles, so in 2 hours it's going to make twice as much, 40 miles. Then the car moving south is moving at 15 miles per hour, which means 2 hours later it has moved 30 miles. In 1 hour 15 miles, so in 2 hours 30 miles. And then at that point, this car, the west car, is 40 miles away. The south car is 30 miles away from the starting point. So z, the distance between these two cars, has to be 50. It's one of the special triangles, or you could have used the Pythagorean theorem to find what z is equal to. So we have all the data about this point. Now, write the equation relating x, y, and z. So Pythagorean theorem tells us x squared plus y squared is equal to z squared. Differentiate with respect to t. So that's going to be 2x times the derivative of x plus 2y times the derivative of y is equal to 2z times the derivative of z. Notice that none of these letters, none of these distances are constant, so I can't plug anything in before finding the derivative. And then we know that x is equal to 40, we found it over here. Dx dt is given to us as 20. Y is equal to 30, we found it here on the side. Dy dt is given to us as 15. Z is 50, and dz dt is what we have to find. So now I divided both sides by 2 to make the numbers smaller. So after you plug these values in, you get 40 times 20 plus 30 times 15 is equal to 50 times dz dt, or z prime if you use the other notation. And then you just solve this equation for dz dt. So multiply 40 and 20, you get 800, 30 and 15, 450. Add them up, you get 1250, and divide both sides by 50, so you get 25. 25 miles per hour is how fast the distance between the cars is changing.